The lifespan of a star the size of our Sun is roughly 10 billion years. In particular, our lovely Sun is about 4.5 billion years old and has already burned through half of its fuel. The next stage of a star's life begins when its fuel runs out and its internal pressure drops. Hello and welcome back to Cosmos Observer. At a speed of over a quarter of the speed of light in less than half a second, a star simply collapses under its own weight and contracts to the size of its core, evolving over time from a gigantic behemoth into a compact and dense object as gravity continues to squeeze. As a result of the star's quick collapse, the higher layers of the star explode, blasting a massive amount of energy and matter into space at the same second, boosting the star's brightness by millions or possibly by the number of aliens. Scientists can observe this flare using very powerful telescopes. However, the light from this explosion doesn't illuminate our globe for a very long period. In fact, the star has long since faded. There are several options. Everything at this point depends on the size of the star. If its mass is less than that of our Sun, the flash will gradually become brighter over the course of several months until reaching its maximum brightness. The energy of the explosion will then begin to dissipate and quiet down gradually. The temperature of the former star will eventually match that of space. Then it'll simply disappear. The more massive the star, though, the more thrilling the events will be. Heavy stars burn through their fuel very quickly and have a significantly shorter lifespan. A neutron star is a unique object that can form when stars that are around 8 solar masses en masse crash into one another. The star ball is just 6 to 12 miles or 10 to 20 kilometers broad, yet it has a half-mile thick coating of hard metal. Neutron stars can weigh up to 2 suns and have a powerful gravitational pull. If you were healthy and fit on Earth, you wouldn't even be able to pick up a needle or a match here because you would be flattened to the surface like a pancake and would never be completely immobile. However, some stars are many times heavier than the Sun. The most puzzling and enigmatic object in the cosmos, known as the black hole, is created by the explosion of a supernova that weighs at least 40 times as much as the Sun. A shock wave spreads outward at first, sweeping debris and material from the former star around like a fog. And at the site of the explosion, only a small dark spot is left. The most weighty thing in the cosmos is this dark emptiness. Since it weighs so much, space-time is spent around it by gravity. Yes, the speed of time will slow down as you get closer to a black hole. You wouldn't even recognize your own home if you were able to approach one of them near enough to spend a few minutes in its orbit. A minute near a black hole is equivalent to a month, a year, or 10 years on Earth, depending on the size and mass of the black hole. However, keeping your distance because even light cannot escape from it due to the gravity of the object. A supermassive black hole is also known to exist to humanity. They progressively increase in bulk and feed on various cosmic objects, much like a predator. Typically, such incredibly big black holes are found at the center of galaxies, and their gravitational pull is so great that numerous stars can be held close by them. Most people see a black hole as a famished monster whose gravitational pull is so great that nothing, not even light, can escape it. Theoretically, nothing can destroy data, according to quantum physics, which explains how everything in the world came to be. We are faced with a conundrum, though. If this nothing also encompasses black holes, at that point, Stephen Hawking had an innovative theory. What if black holes don't actually have event horizons, but instead have perceived horizons? So you can only hold things in place for a short period of time until the energy or matter escapes. A black hole won't be able to erase information, though, in its modified form. Change it to there are no black holes as we know them, if this theory is correct and there is no evident horizon. If so, will there be a big crunch, big rip, big freeze? You can grab a large gulp, I'm sure of it. In 2.8 to 22 billion years, according to many astronomers, the universe may have come to an end. If the cosmos is expanding, this indicates that it originated from a place that was much more violent, like Rhode Island. And if it did have a beginning, it's like to have an ending as well. The manner in which it'll occur, however, is disputed by scientists. A big crunch is one of the most common theories. Gravity will take over as the dominant factor once the universe's expansion slows to a crawl. Planets, stars, and galaxies will collide as the universe contracts as a result. Everything will collapse on itself like the Big Bang in reverse. In a plane with just too many zeros squeezed onto a single screen, it would take you around 100,000 years to go from one end of our Milky Way galaxy to the other. The Sun has enough room inside to hold 1 million Earths. The Sun is around 1,700 times larger than a star known as Uiscudi. In space, gravity connects almost everything to everything else. Galaxies, clusters, and superclusters are all made up of systems which are also parts of galaxies and clusters. The largest in the universe is the Hercules Corona Borealis Great Wall. The length of its name exceeds 10 billion light-years. In the solar system, Mars has the biggest neutral formation. The crater that could accommodate half of the Amazon River across it, the canyon that's nearly 7 times longer than the Grand Canyon, and the peak that is 3 times taller than Everest. Despite being the most plausible theory, there's still evidence that refutes the Big Bang Theory. For instance, one theory proposes that the axis of evil is the cause of the universe's rotation around which all matter revolves. Nearly all big galaxies, including our own, contain a supermassive black hole. Black holes have the ability to draw non-toless charges, planets, and other black holes, eventually combining and uniting with a much larger bulk. Black holes occasionally release jets of stuff into space that are traveling at the speed of light due to their extreme gravity and spinning moment. The phrase great attractor exists. Outside of our galaxy, it is a gravitational anomaly that cannot be seen. The Milky Way and numerous other galaxies are known to be drawn to it, though. The speed of events in Neptune is 1,600 miles per hour, which is 3 times the speed of a commercial aircraft. A minus 397 degree Fahrenheit temperature is reached at the south pole of the moon. Just maybe it is the solar system's coldest place. Compared to Saturn, it has a lower density. That means that it would float if it were dropped into the giant pool, the icy surface of Jupiter's moon Europa. Though it's surrounded by a large ocean of water that extends up to 100 miles below the surface. Previously, it was believed that water ice was a rare phenomenon that only existed on Earth. Even on Mercury and the Moon, it is present throughout the solar system. The stunning rings of Saturn were created when one of its moons broke apart and left behind a belt of cosmic debris. Even some asteroids have rings, albeit they're not as beautiful as Saturn's. Jupiter, Neptune, and Uranus also have rings, although they're not as magnificent. The solar system contains 8 verified planets. Evidence though suggests that there may be a 9th. We simply haven't found it yet. Outer space isn't a perfect vacuum. There isn't a complete vacuum in outer space. It also includes cosmic rays, dust, plasma, and interstellar clouds, in addition to stars and planets. Those are bits of atoms hurling from the solar system's periphery. While exploring space, cold welding is one phenomenon that people should be concerned about. If this type of metal is present in 2 parts that touch, as a result of their link, they become firmly attached. On Earth, the bits are kept apart by water and air, so it doesn't happen. The International Space Station's crew members do not walk on their feet. The skin of their feet begins to peel off since they're floating around and have very soft skin. Because of this, kids must carefully remove their socks. In the absence of this, skin cells will break free and float about in the almost wireless environment. Earthquake on the moon. Moonquakes or earthquakes on the moon are a reality and not a plot device for science fiction. When they do, they happen nearer to the satellite's center than they would on Earth. The gravity of the Sun and Earth is thought by scientists to be a potential source of moonquakes. Possible E-ring system on one of Saturn's moons, Rhea. If astronomers are successful in verifying it, it'll have 3 narrow bands. The universe is only 5% visible planets and stars. The remaining portion, or 68%, is made up of dark matter, which makes up around 27% of the total. There is 95% space after adding everything together. Space is extremely cold, minus 454 degrees Fahrenheit, even in the deepest crevices.